Hi everyone, welcome to this tutorial on binary neural networks. In this video, we'll go through the code step by step to help you understand how to implement BNN using PyTorch. So let's get started. Before diving into the code, let's briefly go over the structure of the neural network. This is a simplified representation of neural network which we are going to train for MNISTS and written digit detection. It consists of an input layer, an output layer, and three hidden layers of sizes 500, 400, and 300. Since we are using MNIST handwritten digit dataset, which contains an image size of 28 cross 28, hence our input layer is of 784 and the output layer is of size 10. In this network, we are not converting the first and the last layer into binary. We are only binarizing the second and the third hidden layers. The binarized neuron now has to perform binarization of input and weight matrices first, before computing weighted summation and applying tanh activation function. With this background, let's start writing the code. First, let's set up our environment. We'll import the necessary libraries and configure our devices. Since I'm using MacBook, it is MPS, not CUDA. Now let's define the hyperparameters for our model. Let's import the MNIST dataset and also data loader. For detailed explanation on the syntax, follow Patrick's YouTube video on PyTorch tutorial. I'll provide the link in the description. Next, we will define our neural network model. This model consists of several layers, including both traditional linear layers and our custom binarized linear layers. Let's walk through the code. The first layer is traditional linear layers. Let's apply batch normalization before applying tanh activation function. The second and third layer are binarized layer. Hence we have to implement binarization class, which I will show you in a bit. Remember that the last layer is a normal linear layer, not a binarized layer. Before going further, let's implement BinarizeLinear class. The BinarizeLinear class extends the functionality of standard linear layer by incorporating binarization. Let's break down the code. In this class, we override the forward method to binarize both input and the weights before they are being multiplied. Now back to neural network class. Here the forward method defines the forward pass of the network where input data passes through each layer sequentially. Now that we have defined our model, let's initialize it and set up our loss function and optimizer. Here we are using cross entropy loss as our loss function and the atom optimizer to update our model's parameter during training. Let's start training the model. We will iterate through our dataset performing forward and backward passes and update the model's parameter. First, we perform a forward pass to get the model's prediction and compute the loss. We perform the backward pass to compute the gradients. Now, here's where straight-through estimator comes in. After computing the gradients, we need to update the non-binarized weights. That is the original weights which was calculated before converting them to +1 and -1. For this, we need to store the original weights for each layer before binarizing them. Hence, we need to modify the BinarizeLinear class, which now include org attribute which stores the original weights. So now, after computing the gradients, we temporarily restore the original weights before updating them. Finally, the optimizer then updates the weights. Then we clamp the weights to ensure that they remain within the binarized range. Now the program is finished, so let's do the training. Now the training is done, we will test our model on the test dataset to evaluate its performance. As you see that the accuracy is 97%, which is great. So our neural network training is successful. Let's save the model. And that's it. We have successfully implemented a binary neural network using PyTorch and trained it on the MNIST dataset. In the upcoming videos, I will delve deeper into several key aspects of the binary neural networks. Here are some topics we will cover. I hope this tutorial was helpful and gave you clear understanding of how BNN work and how to implement them. If you have any questions, feel free to leave them in the comment below. Thanks for watching. See you next time.